Josh invests some amount of money into an account that earns interest at an annual rate of 5.2% compounded semi-annually. If the account is worth $1,436.19 after 3.5 years, find the value of the account 1.5 years after the money was invested. So one thing to notice is that we have things occurring at 3 different times. We have time 0 when the money is initially invested. We know the value of the account after 3.5 years, and we want to know the value of the account after 1.5 years. Anytime you have more than 2 different times that you need to work with, it's probably a good idea to draw a time diagram. So we have 3 times we're interested in: 0, 1.5, and 3.5. Okay, so it says that Josh invests some amount of money at time 0. Well, we don't know how much, so let's just call it P for principal. The annual interest rate is 5.2%. 5.2%, and that's compounded semi-annually. So M is 2. And that tells us that our semi-annual rate is 0.052 divided by 2, which is 0.026. Next, it tells us that the account is worth $1,436.19 after 3.5 years. And we want to find the value of the account after 1.5 years. So, I encourage you to take a minute and see if you can try to figure out how to approach this problem. You might want to pause the video, but just give it a few seconds to think about. Okay, so hopefully you came to the conclusion that the first step in this problem should probably be to solve for P. Doing that, so if we do want to solve for P first, this is very similar to what we did in example 4. I'm going to use 1436.19 as my accumulated value, since that's how much the account is worth after 3.5 years. So 1436.19 is equal to P times 1 plus I raised to the n. Now, at this moment, I'm looking at T equals 3.5, 3.5 years. So I can multiply that by M equals 2 to get 7. Or in other words, in 3.5 years, there are 7 6-month periods. Okay, so now I need to finish out solving for P. I get 1436.19 equals P times 1.196827. Then I can divide both sides by 1.196827, and I get that P is $1,200. That is the amount that was initially invested. Okay, so let me draw that in here in the diagram. $1,200 is the amount invested. So now, if I want to figure out how much money is in the account after 1.5 years, this is just an issue of finding the accumulated value, but using T equals 1.5. So my accumulated value is my initial principal times 1.026, and then I now am using 1.5 as my number of years. 1.5 times 2 is 3. So if I calculate that, I plug all that into the calculator, and I get $1,296.05. So there are actually other ways of doing this problem, but this is probably the most straightforward. So basically what you do is you start by using the value at T equals 3.5, pull back to figure out the value at T equals 0. In other words, you find the initial principal, and then you move forward to find the value of the account 1.5 years later.